understand the principle of lever. So what is the principle of lever? So the principle of lever stands for a load into distance of load from fulcrum. Suppose that this is load, this is fulcrum. So the load into the distance of load from fulcrum must be equal to effort into the distance of effort from the fulcrum. So load into distance of load from the fulcrum is equal to effort into distance of effort from the fulcrum. Whether it is class first, class second or class 3 lever, in trio of the lever this principle is valid. Now see the example. Number 1. Suppose that this is a bar having a fulcrum at 30 centimeter from the load 2 Newton. We are applying an effort at this end. What effort is required to keep the lever in the horizontal position? So we know very well, according to the principle of lever, load into load arm is equal to effort into effort arm. So load into load arm is equal to effort into effort arm. So load is 2 Newton, load arm is 30 centimeter, and effort we have to find out, and effort arm must be equal to, let's see, this is 30. So 30, sorry, this is 80. 80 minus 30, this will be 50. So 80 minus 30, that is 50. So directly they have put effort is equal to 2 into 30 divided by 50. Then it will become 1.2 Newton. So to raise the load of 2 Newton, we require 1.2 Newton of effort. Next example. It is class second lever. Calculate the weight of the load. This is load, this is effort, this is fulcrum. The distance of effort from the fulcrum is 1 meter or 100 centimeter, and the distance of load from the effort, that is 60. So from the fulcrum, that will be 40. So load into load arm must be equal to effort into effort arm. So load we have to find out. Load into load arm is 100 minus 60, that is 40. And effort, that is given 4 Newton. So 4 into 100. So load is equal to 4 into 100 upon 40, that is equal to 10 Newton. Got? So this is second example. Now the third example. It is class third lever. Effort lying between load and fulcrum. So the distance of load from the fulcrum is 80 centimeter. Load is 9 Newton and effort we are applying, that is 12 Newton. So we have to find out the distance of effort from the fulcrum. So see, at what distance from the fulcrum must the effort act to maintain the lever in the horizontal position? So see, load into load arm is equal to effort into effort arm. Load is given 9, load arm at, that is 80, is equal to effort, that is 12. Effort arm we do not know, let that is y. Then y is equal to 9 into 80 divided by 12. So that is equal to 60 centimeter. So at a distance of 60 centimeter from the fulcrum, effort must be applied to maintain the rod at equilibrium. Next topic is law of conservation of energy. What do you mean by the law of conservation of energy? Simply it stands for energy is neither be created nor be destroyed. It can be transferred from one object to another object, or transformed from one form to another form. Means energy can neither be created nor be destroyed. It can be transferred from one form to another. This is the law of conservation of energy. It is also known as the first law of thermodynamics. In class 11 we will study thermodynamics. Now see. Now how to prove that law of conservation? So it is an example that we have to prove the law of conservation of energy with the example of free fall of a body. Suppose that a ball is lying at a point A. Initially it was at rest. So initial velocity is 0. When we leave it, it starts its motion and travel towards down. So at these 3 points, point A, point B, point C, we have to calculate the total energy of the ball, and we have to prove that the total energy is constant or same. So let's see, at point A the ball was stationary, so initial velocity was 0, so kinetic energy will be 0. If the body is not moving, so kinetic energy will be 0. But the height of the ball from the free surface of earth, that is h. So what is the potential energy at this point? That is mgh. So the total energy will be mgh. Okay. Now see, suppose that ball travels and reach at a point B. At point B, what will be its kinetic energy? The kinetic energy will be equal to the change in potential energy from here to here. If we consider the potential energy of ball from this point to this, so the height is x, so potential energy from here to here, that is mgx. This potential energy will be converted into kinetic energy. So what is the kinetic energy at point B? That is mgx. And what is the potential energy at B? The distance from this to this, that is h minus x. So the potential energy will be mg h minus x. When you add these two, so we will get mg h as a total energy of the body at point B. Now similarly, if we reach, the ball reach at the point C, then it travels a distance h. So whatever the potential energy was here is directly converted into kinetic energy. But the potential energy at point C will become 0. So the potential energy at point C, that is 0. And whatever the potential energy was there at A, that is converted into kinetic energy at C. So whether at point A, the total energy is mgh. At B, on adding these two, the answer will be mgh. And at C, the answer is also mgh. So this is the proof that the energy can neither be created nor be destroyed. It actually transformed from potential to kinetic and kinetic to potential again. Now, next topic, we have to explain the conservation of energy with the help of simple pendulum, the motion of simple pendulum. This is the mean position. These are two extreme positions of the body. So at mean position, at the starting of the motion, the body was not in motion, so it does not have kinetic energy. Suppose that we displace the body till a certain point C and leave it. This is the height of the body which it gained. So its kinetic potential energy will be mgh. At this point, the potential energy is mgh. Because when the body reach at extreme point, its motion for a moment becomes 0. So at this point, the body made its motion 0, means it has no velocity. So kinetic energy will be 0. So what is the total mechanical energy at this point C? The total mechanical energy mgh plus 0, that is mgh. Now body moves and reach at point A. Whatever the potential energy it had, that convert into kinetic energy. So what was the potential energy it has? That is mgh. So kinetic energy will become mgh. Because it does not have any distance from the free surface of Earth, so the potential energy will be 0. So the total mechanical energy at point A will be equal to mgh. mgh plus 0, that is mgh. Now due to its inertia, it moves in the same direction and reach at a point B. Like it gains a similar height, that is h. So whatever the kinetic energy it had at point A, that converted into potential energy. What kinetic energy it has? mgh. Or from here you may say the height of the body from the free surface, that is h. So the potential energy will become mgh. Now the kinetic, because at this point, extreme point, body does not move, so the kinetic energy will be 0. So the total mechanical energy will become mgh.